I'm so excited to be here to launch the Testival. I'm really, really excited to launch this thing. Actually, one of my colleagues suggested that maybe for a start, to lift the vibes, we should all speakers get on stage, and dance. However, I'm old enough to remember the launch of Windows 95. And no, I'm not sure that it's a good idea. Nerds can dance. So let's delve right away into what is that Testival thing. So, in a typical talk, we deal with one topic, and you are exposed to multiple insights. And we thought that maybe, just maybe, in a Testival talk, we can cover for you in 30 minutes multiple related topics and many insights. Like try to make the best use of your time, maybe. So the idea to achieve this, we're about to speak here 8 speakers. Each one is assigned 3 minutes to share some testing tip with you. And maybe it's just an experiment. You can get in 30 minutes, being exposed to many, enrich your testing toolbox and techniques and mind. I don't know, let's see, it's the first time we try this. So without further ado, I want to launch the first Testival speaker. And really, should I choose one from Alaska to New Zealand, one person on Earth to launch such thing, it would probably be Kenzie Dodds. Welcome on stage.
Thank you all so much. So I only have 3 minutes, and it doesn't have a timer, so I don't know. It looks like I have 30 minutes? No, I'm just kidding. So there's a spectrum of abstraction. We go from absolutely no abstraction, that's Anna, to all the way to dry, don't repeat yourself. And we have this thing in the middle that I call avoid hasty abstraction, aha. And in testing, the way that plays out, is a little bit like this. That's what I want to talk about. So you're not supposed to be able to read all that code. I see some of you like squinting. You don't bother, it's fine. But when I was working at PayPal, we had a bunch of tests that were similar to this. We were using Express, and at the very bottom there, we were calling our controller function, and we were passing the request to response and next, and then we were asserting that response.json was called properly, whatever. But for response.json to get called properly, we'd have to make sure that the request and response had all the properties on it that it needed. It was like not a big deal, but it was a little bit of a pain. And what would happen is then we'd write another test that looked basically exactly the same. We just copy paste and make a couple modifications. And these are 2 completely different tests. For one, it's all just the JSON is being returned completely differently. But it's hard to know what in all of that nonsense is different. What part of this actually makes the impact between whether we return some posts or whether we return no posts. And so with avoid hasty abstractions and with dry, you can simplify this up. Now, a lot of times, I don't have an example of this, but sometimes you can take dry way too far, where you are just drying up everything in your code base, and it makes you end up building abstractions that need to be tested themselves. And that's not always bad. Sometimes you end up writing libraries that are testing abstractions. But for most of the time, that's not a really great thing to do. And so we want to be conscious of the way that we create abstractions. And this is much easier to tell. You see, okay, the reason that there are no posts is because the user's latitude and longitude are different, whatever the case may be. And your setup function can encapsulate all of the stuff that's common across these different utilities or these different request, response, and next. And that just drastically simplifies your test. So that is avoid hasty abstractions. With testing, you want to wait to build the abstraction until the commonalities are screaming at you, and you don't want to wait too long either. That's it for me. Thank you.
Okay, so you've decided to use TypeScript, and this is a typical class in TypeScript, which get one dependency from outside using IOC principle. And this is the dependency of the class. This is the logger. It has one method called log, and it returns void. When we reach the unit test for this, or integration test, what we need to do is we need to mock the class in order to pass it to the fee service. Okay, so you need to create a mock and put a stub inside with the log function. This is very simple. Everything is nice. And then you go to the logger again and adding some more functions like warn and error. And then everything is gonna break because you need to add the stubs to the mock again. The type is not good enough because we have the awesome logger and we need all the methods inside. So we can change the type. We can put unknown and we can put the awesome logger, but this gives us nothing actually because this is not a real type. And then I want to add some more dependencies to my class, okay? So I have the logger and I have the queue and I have the calculator and I need to create more stubs and to enrich my mocks in order to save the types. So meet JustMock Extended. JustMock Extended aims to solve exactly this kind of problem. Let's see. I'm going to import the mock function from JustMock Extended library. Then I'm going to declare my service under test. And this is where the magic happens. I create a mock using the mock function from JustMock Extended. And everything here is already stubs. I get the mock automatically from JustMock Extended. All the stubs are inside, the types is safe. And then I can pass all my dependencies to my service under test. I save myself a lot of cumbersome work, a lot of tedious work, unpleasant work. I can concentrate on my test. I can do the logic in my test and avoid creating a lot of stubs and mocks. And another solution, which is a similar tooling to JustMock Extended, where everything gets wired in single line, and it's written by me, it's called AutoMock. You can search it on GitHub, and this gives another solution, like JustMock Extended, to mock all the dependency automatically. Thank you very much.
Okay, hi everyone, it's a pleasure to be here. And I have a quick question to ask you. So, how do you test your Express middlewares? So I asked many developers I know, and most of them told me that I have to mock the entire request and response object, and this is right. But so I did a quick research, and what I found out is that the request object of Express includes inside of it 23 different properties, and the response includes 36 of them. So I tried to mock it, and it looks like this. Yes, it's very huge. So I found another solution, which I'm going to show you today. And I'm going to show you in this example a very, very simple middleware, and then I'll show you a test and how I did it in only 4 lines of code. So let's dive into it. This is a very, very simple middleware, and what it does is just to check if a data property exists inside the request body, And if it's not there, then it's going to throw an error saying that this is an invalid data. That's it. Now let's take a look at the test. So the test, everything it does is just to check if the middleware throws an error for an undefined data. And all I have to do is just to import an incredible NPM library, which is node.mox.http, which is going to do all the trick here. And now all I have to do is just to use two different methods. The first one is the create request method, which is going to mock for me the entire object of the request and allows me to insert inside of it everything I need, from the body to cookies, headers, files, everything I need. And as you can see on debug mode, I took an animation. It just mocked everything in one single line of code. The second method is the create response method, which is going to do just the same, but now for the response. And now all I have to do is just to check if the middleware will throw the error when I will insert inside of it as a params the request and the response. And actually, that's it. Now look at my test. It's only 4 lines of code, and it did just that. With the right tools, you can achieve the same. Thank you.
My friends keep telling me to leave this, so let's get down to business. Let's get down to business. Give you one more night to get this. We've had a million nights just like this. So let's get down to business. Let's get down to business. Give you one more night to get this. We've had a million nights just like this. So let's get down to business. Back and forth with the bullshit. I know I said it before, I don't mean it. It's been a while since I had your...
So hi everyone. I want to talk to you about how to get regression tests for free. So how are you going to do it? So the problem that I have in hand is that I have a really big system and it is already deployed to production, and I also have a lot of active users to it. And I don't have that much tests, or I really have low coverage for my system. And I want to look at some complicated code section that I want to refactor, or to fix a bug on, to add a new feature, or to maybe add tests just like that to make my coverage higher. But I want to do that refactor without regressions. So basically you're gonna tell me, Karine, regression tests, right? But then I'm gonna ask you, how would I do my regression tests? Remember, I told you that I have a complicated piece of code. You don't really need to understand it. I am not going to understand it. I need to refactor it, and I don't have the time to dive into it, right? I need my tests now. I want to start refactoring it. So the first thing I need to understand are, what are the test cases? If I'm not going to dive into the code, how would I know what are the test cases? And the second question is, are all the test cases interesting for me? Do I really need all those cases that are not really going to end up in my production environment? So I want to suggest that maybe the production behavior will yield my test cases. So that's what I want to suggest. Basically, to make test cases out of input and output logs from your production. And how would it look like? So the first step would be to add logs to the input and the output. Let's say I am testing this truncate function, and it has a lot of code inside, but just as I enter to the function, I would add logs to the input. And just before I return the value, I would add logs to the result. And then I would deploy it to production and let my users interact with it and let some time pass by. And after some time, I would open my logs aggregator. On this case, it's my console, but imagine Kibana, okay? And here I can see that I have different cases. let's say the string that the truncate function is getting is straightforward, but the options can be undefined. It can be an empty object, an object with a length property that can have different values. And for all those cases, the output would be a little bit different. So these would be my test cases. And these are valid test cases because they're operational on my production environment. And out of those, I would make my test cases. So my test case would be to execute the truncate function on some input, and the expectation or the assertion would be the output of that I have in the log. Some further advantages that I can have out of it. So first of all, my test cases are taken from production, like real data. A second thing is that I'm focusing on test cases that are actually derived from user interfaces. I'm not wasting time to look at cases that maybe are not interesting for me right now. Also, the logs can surface things that I wouldn't think of if I wouldn't look at it. And the nicest thing about this methodology that you can implement it on different levels. It can be on the API level, it can be on the module level, and you can implement it also on the utility function level. So by simple addition of logs in the correct places, you get the free tests for your regression tests. That's
I like diamonds, I like stunning, I like shining, I like $1 million deals. Where's my pen? Bitch, I'm signing. I like those Balenciagas, the ones that look like socks. I like going to the jeweler, I put rocks all in my watch. I like texts from my exes when they want a second chance. I like proving niggas wrong, I do what they say I can't. They call me Cardi, Cardi, banging body, spicy mommy, hot tamale, hotter than a sock.
Okay, I need to click. Okay, so knock knock, who is there? When testing our code, we wish to avoid approaching external services because it's slow. Knock is a tool which overrides the node's http.request function and let you decide the response according to the request. So it's simple. This is I think the most powerful thing about Knock, which is simple. The concept is simple, but you can do a lot with it. So I have here the fake email provider SDK, which is a simple function that call to Axios post request, do Axios post request to my email provider. And I have a typical test for create order functionality. So when adding a new valid test order, then an email should be sent to admin. We have a simple arrange phase, add to order, and a simple API request, what we want to test, that the order is really added, and we sent an email. So how do we test? How can we test this, that the email is sent? Because we don't see any evidence about that email sent in the API. So here how we can do this with Knock. We can create an interceptor which return a scope, and here we call to the API, and now we can check this scope is done, okay? Because the Knock intercept the request that's sent by the mailer SDK. Cool. But because this is only interceptor, I can completely delete the body, and the test is still pass. And what about timeouts and slow requests? How can I test that? So I can do this by take advantage of a request hook. Knock gives us an option to filter request by its body. You see here the payload, email payload is equal to payload, which payload is actually the body we sent. So we can save it in the test scope level, in the email payload variable, and we can assert it. Cool. So now I get a crystal clear error message. Recipient address must to be valid string. Cool. So now what about timeout and things like that? We can also test it with the knock by, so if we have a test when user's service doesn't reply within 2 seconds, return 503. So we can, again, use knock and add a function delay of 5 seconds, okay, which is like out-of-the-box functionality that knock gives us. And now we get 503 because the response was too late. Now it's simple node because a lot of people use Axios. Axios implement the timeout by itself and not following node best practices or the timeout event. So we have to use sign-on fake timers or timers, and we again utilize and take advantage of the Knox request hook to clock to move the clock forward. And again, we get the 503. We are happy. Think twice before using the delay body method because it's actually wait 5 seconds. Okay, there is a delay and delay body, so watch out. Last thing Knox gives us is total isolation. We can disable all net connection, and if, for example, my code is going to Google or something like that, the test will fail because Knox won't allow this request. And enable it only for our server, which is localhost, of course. The server is still can or able to go to things like Redis or database because this is not over HTTP protocol. You can do tons of nifty tricks with the knock, and it's simple. So go use it.
Hey, okay, that's cool. I want to talk about end-to-end testing with backend. And the problem with end-to-end is that everyone thinks about end and end in a different way. So for me, an end-to-end test is not just your API, unless you use only your API, but actually from the UI, from the customer interaction up until the database. Because this is where our customer experience lives. It's not enough that just part of it works. We need the whole experience to be clear. And in order to do that, what we need is, we have, let's assume it's a browser application. We need some way to automate our browser. We need to trigger the request, and it needs to go all the way to the database. And I love Playwright, and I think Playwright is an amazing tool to use for that. And Playwright started about 2 years ago. It's a tool for Microsoft. I don't work for Microsoft. They don't pay me for that, sadly. And they started with a browser automation library, which can automate interaction with the browser. And now they renamed it Playwright Library, and they actually added a layer that they call the test runner, which runs tests. And part of this Playwright test is they have something that is called API context, which interacts with the server. So you can send server requests. You can configure in the test configuration things like what is the best URL that I'm accessing. You can configure things like your headers to send to the server and so on. And then you can use it. So one thing to do with it is to prepare your test data inside the server. So you can make something like a new product. You will get the request, which is an equivalent of Axios, but you have it inside the test built-in, and you can post to your request and send all the data that you want. And this way, when you start the browser interaction, your whole data is ready. You don't need to do everything in the browser. You can also use the same request in order to validate. After the user has done whatever he did, you can again go and make sure that the cart has the item that he put as part of the interaction. And this way, you can test, in fact, the whole customer experience. And Playwright gives you some tools to investigate into it, and this is the traces that it gives you. So what you see here is at the top, you can see all the screens, all the interactions that the automation went through. And for each one of them, if there were a network request, you will see exactly what are the network request. What is the body that was sent? What was the response that we got? And this is great if you need to investigate into, when everything works well, you don't need to do a lot. But if it doesn't, this is a great way to go and investigate what is there. And one last thing, I said I love Playwright. You might want to look into it because I think their test runner is pretty amazing, and it can be in the coming future, in the very soon future, hopefully, a way to replace your existing test runner like Jest. It has fixture, which is a nice concept that most test runners don't use in the JavaScript world. It has, of course, the assertion, everything that is coming from Jest. It can run tests because it is built for end-to-end. It can run tests in parallel. Also, it has sharding built in, so you can split your test across the CI. It exists in the runner. You don't need to run or invent anything. It has parameterized tests, very simply, which you can send them. You can have retries, multiple projects that you can run just part or across different servers, and it has an amazing tool. Thank you.
Let my heart speak. My friends keep telling me to leave this. So let's get down to business. Let's get down to business. Give you one more night to get this. We've had a million nights just like this. So let's get down to business. Let's get down to business. Give you one more night to get this. We've had a million nights just like this. So let's get down.
I'm pretty sure that you encountered this situation at least once. When your code is good, your tests are perfect, but there's still a production bug. Because some of our risks are not related with the functions, the logic, rather things beyond this. Like, for example, your open API, your Swagger or Graph. And I want to see you how you can easily mitigate this type of risk. So let's go with this simple example. You have a post route to get new orders. Then there is one functionality. We want to check if the order already exists. Then we set a field that is called duplicated in the response payload. We also document this API for the user so the client can interact with your API. At some point, naturally, there is a change for request. Don't use anymore a field for errors, rather use a real error. So remove this field and return some HTTP 409 conflict error to the caller. So what does a careful developer do when there is a change? Write a test, right? So by the book, she writes a great test. When having duplicate order, get back an error, right? For a start, the test adds one order to the system. Then we approach again and add another order with the same ID. So obviously this is a duplication. And the result should be, we get back error HTTP in response. All good, everything by the book. Also, all tests pass. Life is good. Expect, there is one small problem. Production bug. Why? Well, the caller of this API tries to interact with it and use that field, duplicated, which was removed, remember? And boom, it failed in production, in the user's face. Because we forgot to update the Open API. Well, even if you're generating automatically your Open API, it would happen because something are manual by definition, like error status code. So how do we solve it? Contract testing? Maybe, but there are simpler techniques, and I want to explore one now. One of the options is to use this nice library, Jest or Mocha Open API, which you just call and provide your Open API document. And then you can write the same test. It's the same one that you read, no need to read it again, exactly the same one. But you can assert for one more thing. Check that the response conforms to the Open API. Now I see you maybe a little bit concerned. What, I need to now repeat again and again and put that line in every test? What if I forget? Reasonable. So here's a nice trick how to avoid putting this line in every test. In your before all, which obviously happens once, if you're using an HTTP client that has the notion of hooks or interceptors, you can intercept every response and just put this there. Now every test that invokes an HTTP request is going to be validated. So this is again the same test like before, but you won't find the word Open API here. It happens automatically, transparently for you. So now if I run this test, it crashes, which is great. And you get that beautiful error message telling you, okay, these are the documented errors, but what I received in practice is not documented. So you fail way before production. And this is without adding one line of code to your test. Every future test would benefit from this additional functionality. And my overarching advice is go beyond functions and functionality. There are risks beyond code, like Open API, so we've just seen migration, database migration, MQ migration, things that you can automatically run as part of your test. Docker build, performance regression, and others. Thank you. Oh, by the way, don't miss the next one.
Oh. First of all, thank you, Junko, for this lovely shirt. So it's a Testival, right? Come on, people. We need to go up. Sorry, I'm going up. Now I'm going down. Let's put in some Latin percussion. Okay, this one looks good. Oh shit. No, not that one. There we go. Okay. But what I really want is some hip hop. Yep. Let's find the beat. Now. I'm old fashioned, people. There we go. Yeah! Are you ready? Whenever testing a database mutation, never test one record in isolation. Always have two in your database and check if the second one was not defaced. Let's take an example, unfortunately real, of a bug I had when not following this deal. Let's write a service of users real and write the delete endpoint with seek wheel. We call delete. This is the endpoint function delete, where we query and do delete. Oh, some of you have found a bug. You are the best. Please, oh, please don't tell the rest. And we should hope that this test that finds this bug so we can have a rest. To write the test, we use A and A and A. Arrange as insert, that's how we pray. Arranging the test is our first priority, so we create a user with authority. There we go, access.post. We create a user with access.post. we get the ID back. Now that we've arranged the test so nicely, we act and delete the user with that ID. Access.delete, 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 access.delete. Then now to have the test be completed, we assert that the user has really been deleted. Oh, we get this user and the status is equal to 404. We run the test and it passes. Ahoy! Onward to production, our service we deploy. Onward to production. Alas, the first time this feature is used, it deletes all our users and my echo is bruised. We worked the whole weekend to restore the table and return the system to condition stable. But where is the fucking bug? I swear, so I look at the SQL. Oh no! I forgot the where. Oh no! I forgot the where. Oh no! Ha! But I had a test, I do declare, and it passed with no problem and with some flair. And why did the test pass? Now I know. I forgot the first rule of mutation test flow. Remember, whenever testing a database mutation, never test one record in isolation. Always have two in your database and check that the second one was not defaced. Thank you. Woo! What? Our code deleted the user. That's true, but unfortunately deleted them all at you. And nothing in our test we had did that we didn't delete all the rest. Come on. So let's now fix the test today. Instead of one user, we add two to the fray. Two, we add two to the fray. And now we add what before we missed. We check that the second user still exists. We run the test and it passes ahoy. Onward to production, our service we deploy. And remember to chant whenever we can this small refrain, which is a plan. Whenever testing a database mutation, never test one record in isolation. Always have two in your database and check that the second one was not defaced. Whenever testing a database mutation, never test one record in isolation. Always have two in your database and check that the second one was not defaced. Thank you. And nerds can dance. Woo! Thank you, Yoni, for this amazing idea. Woo!